Hello, this is Kusuma Tummala, Assistant Professor, Department of Mathematics, VNR VJT. Previous lecture we discussed Fourier series and its application. Now today we'll concentration on deriving the Euler's quotients and solving the related problems of Fourier series with a period of 2-5. So before going to the Euler's quotients, first you have to remember some basic important integral formulas for solving the Fourier series. Already I discussed in the previous class, just I recall these integral formulas now. So what is the value of sine n pi? It is 0. Cos n pi value is equal to minus 1 whole power n. Sine n pi value 0, cos n pi. So cos 2 pi. Cos 2 pi is equal to 1. Cos 3 pi value minus 1. Remember these formulas, it is helpful for solving the Fourier series expansion. And also one more formula, integral c to c plus 2 pi sin nx dx value is equal to 0. Similar manner, integral c to c plus 2 pi cos nx dx is equal to 0. Integral c to c plus 2 pi sin mx into cos nx dx is also 0. So if it is m not equal to n as well as m is equal to n case, both the case, this integral value is 0. Integral is sin mx cos nx. This integral value becomes to 0. And integral c to c plus 2 pi sin mx into cos nx, sin nx. Now it is 0, m not equal to n case, and pi, it is m is equal to m. It is important formula for solving the integral equations. M not equal to n, it is 0, m is equal to. Similar manner, integral c to c plus 2 pi cos mx into cos nx dx is equal to 0. M is equal to n case, m not equal to n case, and m is equal to n case, it is pi. And also a very important intermediate level formula, integral e power ax into sin bx is equal to e power ax by a square plus b square, a sin bx minus b cos bx. And similar, integral e power ax into cos bx is equal to e power ax by a square plus b square, a cos bx plus b sin bx. So this is a basic integration formulas for useful for solving the Fourier series expansion. Please remember these formulas. Next, move to next slide for solving the Euler quotients. So it is the Euler quotients helpful for finding the values of A0, A1, Bn. So here I consider the period is 2 pi. So my period is 2 pi. Length means here period is 2 pi. Now I am going to solve the A0 value. You know that suppose my function f of x satisfies the Dirichlet condition. So what are the Dirichlet condition? You know, total 4 conditions are there. Dirichlet condition. One is it is a must be the periodic function. Here period with 2 pi, and second one is the function f of x is finite and integral value also finite, this and also singular value decomposition. And third one is the function f of x is piecewise continuous in the interval c comma c plus 2 pi, and last one is f of x has a finite number of maximum minimum. So whenever your function f of x satisfies these conditions, then you have to apply the Fourier series expansion. So now suppose the f of x is satisfied this condition, this f of x can be written as a0 by 2 plus summation n is equal to 1 to infinity. This is a series, is infinite series. An cos nx plus summation n is equal to 1 to infinity bn sin nx. This is the expansion of Fourier series expansion, and the terms are infinite. So your function expressed as sum of sine and cosine terms. In this expansion, we have to calculate the value of A0, An, Bn. These 3 values you have to find out. So how to calculate, just I will explain. The first one, to find A0. So write the series f of x is equal to series f of x is equal to a0 by 2. This is the Fourier series expansion. A1, the first term cos x, put n is equal to 1, n is equal to 2, a2 cos 2x plus so on. Similarly, go for this expansion bn, b1 sin x plus b2 sin 2x plus so on. So this is the f of x. So this f of x integrating with respect to x with the interval c comma c plus 2 pi. So now take the integral c to c plus 2 pi f of x dx. This is the given function. Apply integrating on both sides. A naught integral c to c plus 2 pi a naught by 2 dx integral c to c plus 2 pi a1 cos x dx plus integral c to c plus 2 pi a2 cos 2x dx plus integral so on integral c to c plus 2 pi b1 sin x dx plus integral c to c plus 2 pi b2 sin 2x dx plus so on. So the above Fourier function I applied integration on both sides with the limit c to c plus 2 pi. So now go for next. To find a naught, integrate in the left hand side term is as it is c to c plus 2 pi f of x dx. In the right hand side term, a naught by 2 is the constant, a naught by 2 times of integral c to c plus 2 pi 1 dx. And next one a1 integral c to c plus 1 2 pi cos x dx plus a2 integral c to c plus 2 pi cos 2x dx plus so on. Now b1 terms, b1 integral c to c plus 2 pi sin x dx plus b2 integral c to c plus 2 pi sin 2x dx plus so on. Now a naught by 2 integration of 1 with respect to x is x c to c plus 2 pi. So the previous slide you observe that the formulas given integral formulas. What is the integral value of integral c to c plus 2 pi cos dx is 0. a1 into 0, this term is 0 plus what is the integral value of this one, also 0. b1 into 0, b2 into 0, all the integral values except a naught by 2 quotient, remaining all the integral values are 0. You know that the basic formula integral c to c plus 2 pi cos nx dx is equal to 0. So n is equal to 1 case, this is a term, n is equal to 2 case, this is a term, and similar manner integral c to c plus 2 pi sin nx dx is equal to 0. So n is equal to 1, this term is 0, this term is 0. So the remaining one a naught by 2 upper limit minus lower limit in the substitute in the x c plus 2 pi minus c. So c cancel, you get c integral c to c plus 2 pi f of x dx is equal to a naught by 2. From this equation, what is the a naught by 2 into 2 pi? So 2 cancel. So from this equation, a naught is equal to 1 by pi times of integral c to c plus 2 pi f of x dx. So here I derive the value of a naught So remember the formula of A naught is equal to 1 by pi times of integral c to c plus 2 pi f of x dx. This is the equation number 2. So this is the value of A naught. So go for an. So to find an, again take the Fourier series expansion f of x is equal to, what is the Fourier series expansion? A naught by 2 plus a1 cos x plus a2 cos 2x, so on. In the between your nth term also there, an cos nx plus so on, b1 sin x plus b2 sin 2x, so on, bn sin nx plus so on. This is the Fourier series expansion. Now, this f of x multiply with cos nx, then you get f of x cos nx is equal to a naught by 2 cos nx plus a1 cos x into cos nx plus a2 cos 2x into cos nx plus so on, an cos nx into cos nx is cos square nx plus so on, plus b1 sin x into cos nx plus b2 sin 2x into cos nx plus so on, bn sin nx into cos nx plus so on. Now integrating on both sides with the limit c to c plus 2 pi. So integrating on both sides with the limits c comma c plus 2 pi. So I take the integrating on both sides, integral c to c plus 2 pi f of x cos nx dx is equal to integral c to c plus 2 pi a naught by 2 cos nx dx plus integral c to c plus 2 pi a1 cos x cos nx dx and integral c to c plus 2 pi a2 cos 2x cos nx plus this term is an integral c to c plus 2 pi an cos square nx so on plus integral c to c plus 2 pi b1 sin x cos nx plus integral c to c plus 2 pi b2 sin 2x cos nx plus bn integral c to c plus 2 pi bn sin nx cos nx plus so on. So after applying the integration, you get this equation. You observe that the first term of the right hand side, integral c to c a naught by 2 is the constant, bring outside of the integration. Then you get integral c to c plus 2 pi cos nx dx. What is the integral value? This one, 0. So the integral value of the first term is 0. And integral value of cos x cos nx, this also 0. So integral value of cos 2x into cos nx, this term is also 0. So this is, you have to calculate integral value. V1 sin x cos nx. This is the indication value also 0. Sin 2x, here dx sin 2x cos nx is also 0. And here also 0. Except this term, all the terms integrals are zeros. So you can write that equation. Integral you finally get after integration. In the left hand side you get, the equation is left hand side, you get integral c to c plus 2 pi f of x cos nx dx is equal to, the first term is 0, second term is 0, all the terms are 0 except nth term of the cos nx. So that means an is the constant. Integral c to c plus 2 pi cos square nx dx. Cos square nx. Remaining all the terms of the integral values are zeros. Now start the integration of this term. And integral c to c plus 2 pi cos square nx formula 1 plus cos 2 nx by 2 dx. 1 plus cos. So you know that intermediate level cos square x is equal to 1 plus cos 2x by 2. Use this formula. So it is now an by 2. 2 is the constant term. Integral c to c plus 2 pi. You get 1 plus cos 2nx dx. Now start the integration of this one. An by 2. Integration of 1 with respect to x is x, and integration of cos 2nx, integration of cos 2nx is equal to integration, or you can observe that this also can write easily for the integration of 1 is x c plus 2 pi, and next term is integral c to c plus 2 pi cos 2nx dx. So I split the two terms. First term is 1, second term is cos 2nx. What is the integration of 1? X, and second one is cos 2nx. So this integral value already you know that this integral value is 0. Then you get an by 2. X upper limit is a c plus 2 pi minus c, and c are cancelled. You get an pi, 2 also cancel. So you get an pi. After a simplification you get an pi integral c to c plus 2 pi f of x cos nx dx is equal to an. From this, an value is equal to 1 by pi times of integral c to c plus 2 pi f of x cos nx dx. So remember this formula. What is a naught value? A naught is equal to 1 by pi times of integral c to c plus 2 pi f of x dx. An is equal to 1 by pi times of integral c to c plus 2 pi f of x cos nx dx. Now going to next one is to find bn. For that, multiply both sides of the equation by sin nx. Here you can multiply with sin nx, integrating with respect to, with the limit expects to x with the limit c to c plus 2 pi. Now the equation number 1, multiply with sin nx and integrating with respect to c to c plus 2 pi. Now let us start. So your left hand side is f of x function. This function multiply with sin nx and integrating with respect to c c plus 2 pi dx. And coming to the right hand side, the first term is a naught by 2. A naught by 2 is a constant. Integral c to c plus 2 pi multiply with sin nx dx. Next term is a1 integral c to c plus 2 pi cos x multiply with sin nx dx. Integral a2 integral c to c plus 2 pi cos 2x sin nx dx. and in the between nth term is also there. You get a term an integral c to c plus 2 pi cos nx into sin nx dx, so on. Now start the b1 integral c to c plus 2 pi sin x, sin x is multiple with sin nx dx, plus so on. In between bn term, bn into integral c to c plus 2 pi sin square nx dx, plus so on. This is a series, is infinite series. So now you observe that in the right hand side part, integral c to c plus 2 pi sin nx term is 0. Cos x into sin nx, this integral also 0. Cos 2x into sin nx dx value is also 0. And integral of cos c to c plus 2 pi cos nx into sin nx also 0. And integral of c to c plus 2 pi sin x into sin nx also 0. Now here these terms except remaining all the integral values are 0. So the above equation becomes integral c to c plus 2 pi f of x sin nx dx. This value is equal to bn times of integral c to c plus 2 pi sin square nx dx. The remaining all the terms, integral terms are 0. You get only one term, that is the bn term. So now again bn is equal to integral c to c plus 2 pi. This sin square nx can be written as 1 minus cos 2nx by 2 dx. Now, so this integral in the left hand side, what you have? C to c plus 2 pi f of x sin nx is the left hand side term. In the right hand side, you have bn times of integral c to c plus 2 pi 1 minus cos 2nx by 2 is the constant dx. Now start integration. Before integration is split into two terms. Integral c to c plus 2 pi 1 dx minus, this can be written as integral c to c plus 2 pi cos 2nx dx. bn by 2 is the multiple of these two terms. bn by 2 times of, now let us start the integration of 1. 1 is x c to c plus 2 pi with respect to 1 with respect to x. This term, again this integral value is 0. Now bn by 2 times of upper limit c plus 2 pi minus c. So this is equal to bn by 2 times of c cancel, you get 2 pi. So here 2 cancel, you get a bn pi. From above derivation, you get bn value is equal to 1 by pi times of integral c to c plus 2 pi f of x sin nx dx. So here by using the this a naught, a and bn are called as Euler quotients derived here. So the finally you get that the formulas, the Fourier quotients of a naught, a and bn, when the integral length is 2 pi, a naught value, what is the a naught value? 1 by pi times of integral c to c plus 2 pi f of x dx. an is equal to 1 by pi times of integral c to c plus 2 pi f of x into cos nx. bn is equal to 1 by pi times of integral c to c plus 2 pi f of x sin nx dx. Sin nx dx. So remember these two formulas. So finally, so here finally you can write when your interval is, what is the interval? F of x here, c2 interval is the previous interval c comma c plus 2. The corollary one, if you put a c is equal to 0 in the above interval, then your interval becomes 0 to 2 pi. Then the formulas reduce to, what is the Fourier series? F of x is equal to a naught by 2 plus summation n is equal to, start from 1 to infinity, a n cos nx dx plus summation n is equal to 1 to infinity, sorry, here dx is not integral term, it is a summation, bn sin nx, where a naught value, a naught is equal to, just now I derived 1 by pi times of integral c to c plus 2 pi f of x dx, a naught value. An is equal to 1 by pi times of integral c to c plus 2 pi f of x cos nx dx. This is the L. Bn is equal to 1 by pi times of integral c to c plus 2 pi f of x sin nx dx. So whenever you have interval c to c plus, just you have interval now. What is the interval? 0 to 2 pi. Then this formula becomes 1 by pi times of integral 0 to pi f of x dx. I put c is equal to 0 here. So then becomes 0 to 0 plus. Similar manner, 1 by pi times of, put c is equal to 0. Integral 0 to 2 pi, 0 to 2 pi f of x cos nx dx. Here, here also in this formula put c is equal to 0. 1 by pi times of integral 0 to 2 pi f of x sin nx dx. When put c is equal to 0, the a naught value is 1 by pi times of integral 0 to 2 pi f of x. An value is 1 by pi times of integral 0 to 2 pi f of x cos nx. Bn value is equal to 1 by pi times of integral 0 to 2 pi f of x sin nx. So the corollary 2. Making c is equal to minus pi in the interval minus pi. So what is the interval? C is equal to minus pi. Your interval is c comma c plus 2 pi. So put c is equal to minus pi. Here minus pi comma minus pi plus pi. Then interval becomes minus pi less than x less than pi. Minus pi less than minus, c is equal to minus pi plus 2 pi. Then you get minus pi less than pi. So the formula reduced to, and the formula a naught value. So first, what is the Fourier series expansion of f of x? As usual, a naught by 2 summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx, where a naught is equal to, in this case, what is the interval? 1 by pi times of, put c is equal to minus pi to pi f of x dx. An is equal to 1 by pi times of integral minus pi to pi f of x cos nx dx. Bn is equal to 1 by pi times of integral minus pi to pi f of x sin nx dx. So here the corollaries are, when put c is equal to 0 in the interval, you get the interval are 0 to pi, 2 pi, and next you get the interval c is equal to minus pi, you get the interval minus pi to pi, the corresponding formulas. So you have to remember these two formulas for solving the Fourier series expansion. The f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. What is the a naught value? 1 by pi times of integral 0 to, here the interval start from minus pi to pi f of x dx, and an is equal to 1 by pi times of integral minus pi to pi f of x cos nx. Bn is equal to 1 by pi times of integral minus pi to pi f of x sin x. Let us discuss one example based on the Fourier series expansion in the interval 0 to 2 pi. So here I consider one example. Obtain the Fourier series for f of x. F of x is equal to e power minus x in the interval 0 comma 2 pi. So here period is 2 pi. So this is the function is periodic function, as well as you obtain the Fourier series means it satisfies all the conditions for the that conditions means Dirichlet condition. The satisfied f of x. Now let us this function is the exponential function, express sum of the sine and cosine terms. So first take the given function. So now I will start the solution. What is the given function? Given function f of x is equal to e power minus x. So first I will calculate the value of a naught, after that an, after that bn, and substitute these values into the Fourier series expansion. This is a procedure for solving the problem. Let us start finding the a naught. To find a naught, to find a naught value. So what is the formula for a naught? For calculating a naught is equal to 1 by pi times of integral. What is the interval? 0 to 2 pi, 0 to 2 pi here, f of x dx. This is the formula for a naught. A naught is equal to 1 by pi times of integral 0 to 2 pi f of x. So in the given function, what is the given f of x? E power minus x. So 1 by pi times of integral 0 to 2 pi, replace f of x value is e power minus x dx. So 1 by pi times of, so start the integration of e power minus x. So integral of e power ax dx is equal to e power ax by a plus c. This is the basic formula of integration of e power x. Use e power minus x and a value is minus 1 by minus 1 0 to 2 pi. So 1 by pi times of upper limit is 2 pi e power minus 2 pi by minus 1 minus e power minus x is 0, lower limit value by minus 1. So you can write, simplify this part, 1 by pi times of e power minus 2 pi by minus 1, e power minus 0 value 1, 1 by minus 1, it is minus of minus plus 1. So finally you got a naught value. What is a naught value? So remember a naught is equal to 1 by pi times of 1 minus e power minus 2 pi. This is the value. So just I read it. The first I write 1, after that minus e power. So remember a naught is equal to 1 by pi times of 1 minus e power minus 2 pi. Next go for finding the value of bn. So put the heading an. So to find an value. An, after that you go for bn. So to find an. So for finding the an, recall the formula. What is the formula? An is equal to 1 by pi times of integral 0 to 2 pi f of x cos nx dx. This is the formula, 1 by pi times of integral 0 to 2 pi f of x cos nx. So 1 by pi times of integral 0 to 2 pi. What is f of x? E power minus x cos nx dx. For solving this integration, you remember the formula. What is the formula? E power ax into cos bx dx. The formula is e power ax by a square plus b square a cos bx plus b sin bx. A cos bx plus b sin bx. A cos bx plus b sin. So what is the a value? Compare with what is the a value here? Minus 1, and compare with this cos bx. B value is n. B value is n. A is equal to minus 1, B is equal to 1. Substitute these values into the formula. This is the integral formula. Now again start is equal to 1 by pi times of. In the place of this integration, I use this formula. E power minus x by minus 1 whole square. B square means n square minus 1 cos nx plus n, b value n sin nx. The limits varies from 0 to 2 pi. So 1 by pi times of e power, so e power minus x by a value by n square plus 1 minus cos nx n sin nx 0 to 2 pi. This is the integral value. Now substitute the limits of this integral. What is the upper limit? 2 pi, lower limit 0. So put upper limit in the place of x. Now let us start 1 by pi times of upper limit e power. In the place of x, I replace the value 2 pi by n square plus 1 minus cos n pi is 2n pi plus n times of, just you have to don't replace the value in the place of n. N is the integer, so your variable is x. In the place of x is you can replace the 2 pi cosine 2n pi upper limit. This is the upper limit value minus lower limit. What is the lower limit in this case? 0. E power minus 0 by n square plus 1 and minus cos 0 n 0 time n is the integer sine 0. Just I replace the value. Now simplify this one. I write in the an value here. So here an is equal to 1 by pi times of e power minus 2 pi by n square plus 1 n square plus 1 minus cos 2n pi. What is the value of minus cos 2n pi? Cos 2n pi value is equal to 1. Cos 2n pi value is equal to 1. Sin 2n pi value is equal to 0. Sin 2n pi value is equal to 0. Cos 0 is equal to 1. Sin 0 is equal to 0. Replace these values in this equation. So put the first term is minus 1, 0. Second term vanish, minus e power 0 1 minus 1 by n square plus 1. Next term minus cos 0 1, here minus 1, so plus 1. Here minus of minus cos 0 1 minus of minus plus sin 0 is 0. So now finally get a naught is equal to, in these two terms the common is 1 by n square plus 1 into pi 1 minus e power minus 2 pi. This is the an value. An is equal to 1 by n square plus 1 into pi e power. So this is the an value. Now let us go for bn value. So bn value is equal to, now find out the bn value. To find bn is equal to for remembering the formula, what is the formula for bn? 1 by pi times of integral 0 to 2 pi f of x sin nx dx. This is the basic formula of Euler quotient Bn. Now, what is f of x given in this case? E power minus x. Bn is equal to 1 by pi times of integral 0 to 2 pi f of x is equal to e power minus x sin nx dx. F of x. Put the f of x is equal to e power. Now again recall the formula. Integral e power ax into sin bx dx is equal to e power ax into sin bx is equal to e power ax by a square plus b square a sin bx plus b cos bx. A sin bx plus b cos bx. Now a value here, in this case a is equal to minus 1, A is equal to minus 1, B value is n, B is equal to n. So start the integration this one, Bn is equal to 1 by pi times of integral 0 to 2 pi limits. So now I will write the formula e power minus x by a is 1 minus 1 whole square 1 b n square minus a1 sine nx bn n cos nx. The limits varies from 0 to 2 pi. Next, put the upper limit minus lower limit. So 1 by pi times of upper limit is 2 pi e power minus 2 pi by 1 plus n square sine. Already I told in the above slide, sine 2n pi value. What is the sine 2n pi value? 0. This term is 0. N times of cos 2n pi 1. It is getting n here. Cos 2n pi 1 and 1 into n minus, this is the upper limit value, minus lower limit 0 e power 0, it is 1 by 1 plus n square sine 0 0 cos 0 1, it is getting n. This term is 0 cos after substituting the upper limit. So close the bracket. 1 by pi times of, here n is common and also 1 plus n square is common. The remaining term is e power minus 2 pi minus 1. So this is the value of Bn. Bn is equal to 1 by pi times of n by n plus n square into e power minus 2 pi minus 1. So you calculate a naught value and an, bn. These values replace you to the Fourier series expansion. So your expansion f of x is equal to a naught by 2 summation n is equal to 1 to infinity an cos nx summation n is equal to 1 to infinity bn sin nx. So f of x is a given function e power minus x. So just back your slides, what is the a naught value? So see the a naught value, remember 1 by pi times of 1 minus e power. So replace that value here, 1 by pi times of 1 minus e power minus 2 pi by 2. This is a naught value. Plus summation n is equal to 1 to infinity an value. An, what is an value? Just here 1 by, here an value is 1 by n square plus 1 into pi 1 minus. So replace this value an is equal to 1 by n square plus 1 pi 1 minus e power 2 minus 2 pi into cos nx plus bn value. What is the bn value? Just see the bn value. So 1 is the previously written the an value. Now bn value 1 by pi times of n by 1 plus n square into e power minus 2 pi minus 1. Put this value here. So summation n is equal to 1 to infinity. Replace bn value n by 1 by pi times of n by n square plus 1 e power minus 2 pi minus 1 into sin nx. So just I replace bn value and an value. So now e power minus x by 1 by 2 pi 1 minus e power minus 2 pi. So here the constant term is 1 by pi and 1 minus e power minus 2 pi. The expansion is n to 1 to infinity cos, first n is equal to 1, replace cos x by, put n is equal to 1, 1 square plus 1, it is 2. Next n is equal to 2 cos 2x by 2 square plus 1, n is equal to 2 square plus 1, it is 5, plus so on, plus here the expansion of 1 by pi is again constant, e power minus 2 pi minus 1 is the constant. Expand this one, n is equal to 1 by 1 square plus 1 sine 1x plus 1 by 2 square plus 1 sine 2x plus so on. this is the Fourier series expansion of e power x. E power is the exponential function. This can be expressed as sum of sine and cosine terms. So this is the Fourier series expansion. And practice these questions similar manner. Here the function is x minus x square. The x limits varies from minus pi to pi. So c is equal to minus pi case. And second problem, f of x is equal to x sin x in the interval 0, 2. So calculate a naught, a n, b n. After that, substitute these values into your Fourier series expansion. Then your function is expressed as sum of sine and cos finite. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.